Hi, this is lesson 4.5b, writing a function rule. You should be using your notes to help you, or taking notes to help you complete this. So we're going to begin with problem number 1. So it's an archery club, and it charges an annual membership fee of $65 plus $2 per visit. And we're wanting to write a function rule for the total cost of belonging to the club if you make V visits in a year. And then there's another question as to how much it would cost you if you use the club 15 times in a year. So the first thing we're going to do is find that really important information, and that's this $65 plus $2 per visit. That's what's telling us what's happening in the problem. And from there we can make a table using that information. So if I don't go at all, I still have to pay $65 because that was the cost of the membership fee. If I go one time, it's that $65 plus the $2 on my visit, which makes me pay a total cost of $67. If I were to go 2 times total, that would be $69 because I would add another $2 per visit. And then 3 times would be a total of $71, and that pattern continues. You can see there that as I'm going down here, my Y values are changing by adding 2 each time. Okay, as my X values add 1 every time. So my constant rate of change is 2 over 1, or just 2. And that's important to note because as we're making our function rule, we want to talk about this in terms of total cost. So C, and we want to use letters that help represent the situation. It makes it a lot easier. So the total cost is the C equals, and then if we want to make V visits, meaning we don't know, we're going to use this function rule of 2 over 1, and that's going to, 2 over 1 is the same thing as 2, and then our V is just replacing X there, so Y equals so C equals that box, X plus box is what we're working with. So Y equals that box we just filled in with our constant Y over X change. V is just, instead of the letter X, it's just a variable, and then plus box. And so we want to find that box. That's when X is 0. And if we look at our table here, we can see X is 0 at 65, so plus 65. And this makes sense for words also because we have $65 plus $2 per visit, and that math word there means multiplication. We're multiplying every visit, and we don't know how many visits we're having. That's V, so 2V. Because the commutative property, you could also rearrange it and just say 65 plus 2V. Either way works. So once we have this, we can then answer our second question, which is how much would it cost if you use the club 15 times in a year? So we're going to plug in that 15 for V. V is the visits in a year. So C equals, I'm going to use the same color here. C equals 2, and then we're going to plug in a 15 there, like I said. Everything else stays the same. And then we just do math here. So 2 times 15 is 30, plus 65 will give us our total cost. And then 30 plus 65 is 95. So $95, labeling because it's a real life situation, $95 will be the cost to go to the club 15 times in 1 year. All right, problem number 2. To prepare for an upcoming road trip, you fill your 19-gallon gas tank. You estimate that your SUV will use about 3 gallons per hour. Write the equation to model the amount of gasoline, G, remaining in your tank after H hours. So the first thing we want to do, the table is really helpful just because it helps see what's happening in the problem. So if we look at our key information, that would be that we have a 19-gallon gas tank and that we are using about 3 gallons per hour. Okay, so if I don't travel anywhere at all, I'm going to have 19 gallons of gas because that's how much I filled my tank up with. It's full. Okay, then if I go 1 hour, I'm using 3 gallons per hour. So I've used 3 gallons, and that would give me 16 in my tank. I go another hour for a total of 2 hours. That now I've used 3 more gallons, and then I use 3 more gallons, and that pattern will continue on and on. To write the rule, we want to model the amount of gasoline G remaining in the tank. So G equals, and then finding the pattern here, you're noticing that here that we were subtracting 3 every time. Okay, as our X value changes, we're adding 1 here. So our constant change is -3 over 1. That's our Y over X pattern. Okay, so then I can plug that in here. -3 over 1 is the same thing as -3. And then instead of using X, we are going to use H for hours. And then the last part of that formula is to find when X is 0. So if we look here, we see that when X is 0, Y is 19. So it's going to be plus 19. There's our function rule. You could also reverse it. G equals 19. And then that -3 goes with, so 19 minus 3H would also work as your function rule, either one. Remember here that the -3, the sign goes with it, okay? So you can kind of see that there. Okay, when you reverse it. Alrighty, next problem, number 3. Write a function rule for the area of a rectangle whose length is 3 inches more than its width. What is the area of the rectangle with a width of 7 inches? And so you'll see that's not written in here, but that's the extra information that we needed to know, okay? So we're talking about area. Remember, area formula for a rectangle is A equals length times width. And so we're going to use that as we fill this out, okay? And then we have this rectangle here. The length is 3 inches more than the width. So we have a length and we have a width, and it doesn't matter which one, length, width, it doesn't matter. What we do know is that the length is 3 inches more. Actually, I'm gonna reverse this just so my picture makes a little more sense here. Like I said, it really doesn't matter, but visually this will make more sense. So the length is 3 inches more than the width, and that's our key information. So I'm gonna take that length and I'm gonna make it 3 inches more than the width. So 3 inches more than, that means adding the width. Okay, so now as I write my formula, I'm just going to fill in this information. So A equals my length, which I just replaced, to be 3 plus W. And then we still have the times W here, but notice that we're grouping this together, this whole length here, so we do need parentheses. And that looks a little funny. The other way we could write this is just bring that W around to the front. Now it looks like the distributive property, which is a little bit more commonly known. You can also go one more step and distribute. Okay, and when you do that, you get A equals 3W plus W squared, and we like to rewrite that just so the order is that the squared comes first. It's just a math thing. Okay, so this would be your very final rule. Then to answer the question, it says, what is the area of a rectangle with a width of 7 inches? So that's the part that's missing on your notes page. So I'm just going to show you really quick what that's going to look like. You're going to plug in a 7 for the width. So anywhere you see a W, you're going to put a 7 and then solve. So A equals 7 goes in that spot, and a 7 goes in that spot. So 7 squared is 49 plus, and then 3 times 7, which is 21. 49 plus 21 gives you 70. So the answer to that question would be that the area would be 70 inches squared. All right. Problem number 4. We're going to speed this up a little bit. As you can tell, there's no more tables, but you could make a table. It's a great strategy if you get stuck for finding the rule. So from an elevation of negative 20 meters relative to the surface of the water, a bottlenose dolphin whale, a bottlenose whale dives at a rate of 108 meters per minute, right of rule, that gives the whale's depth as D as a function of time. And then we have another question, but we're not going to worry about that right now. What we need to know is that we are at an elevation of negative 20 meters, and then that the whale dives at a rate of 108 meters per minute, okay? So we're going to write a function rule about that. So the whale's depth, so D equals, and where is the whale starting? Well, it's starting at negative 20 meters, and then it's diving down at a rate of 108 meters per minute. Per means multiplying. Okay, every minute we're multiplying by the amount of time that goes by. So negative 20 minus that 108, and then as a function of time, so we're going to use T for my variable here, and that's per minute. We don't know how many minutes, so we're going to use T there. So 108T. You could also rewrite it, or you could use M for minutes too. You could also reverse this, so that is D equals, and remember the signs go with, so negative 108T minus 20. What is the whale's depth after 4 minutes? It doesn't matter which formula you use. Here you're talking about 4 minutes, so you're going to plug in for time, which would go here in that one, or if you're choosing that first one, it would go there. So D equals, and I'm going to use that first one, minus 108, plug in a 4 in that spot, and then I just do the math. Negative 108 times 4 is negative 432, or you can just do subtraction. And then negative 20 minus 432 is negative 452 meters. Number 5. A bottle holds 8 teaspoons of vanilla. The amount of vanilla remaining in the bottle decreases by 2 teaspoons per batch of cookies. Write a function rule. All right, so important information, 48 tablespoons, and it is decreasing by 2 tablespoons per batch. So writing a function rule here for the to represent the situation. So the vanilla bottle, so you could use B for bottle, you could, no, you don't want to use B for bottle because a B is for batch. So I'm going to use V for vanilla equals, and then we're starting with 48. And then what's happening is that we're decreasing, so subtracting, by 2 teaspoons per batch. And remember, that's a multiplication word, and we don't know how many batches, so that's why we're using the letter B. So 2B. Again, you could reverse this around, and it would be V equals negative 2B plus 48. And then how much vanilla remains after 5 batches of cookies? We're going to plug in the number 5 for batches, so in either of those spots, and evaluate. So V equals 48 minus 2 times the number of batches, which is 5. 2 times 5 is 10. 48 minus 10 is 38. So 38 teaspoons of vanilla. Last but not least, the general admissions tickets to the fair cost $9.50 per person. All-day ride passes cost an additional $12.50 per person, and then you also need to pay for parking. So a lot going on here. Write a function rule for the cost of going to the fair on Saturday evening at 6 p.m. So that's key information. We have to look at the table here for parking. We are entering after 4 p.m., so that's going to be $10 for parking. And then we also have a general administration. Admin is $9.50 per person. And then we have $12.50 per person for those ride passes. Okay, so to write a function rule, I'm talking about the cost. So C equals, I have $9.50 per person. So $9.50 times the number of people. So you can use any letter you want. X would be appropriate here, or P for person. It doesn't matter. And then, so that's $9.50 plus the passes of $12.50 per person, and then parking on top of that. Parking though is just a flat rate of $10. So because it's per here, remember that's multiplying. Okay, this one's not. I can combine like terms here. $9.50 and $12.50 can combine together. C equals 22P plus 10 then is my final function rule. And then I have a family of 6 people. So that's going to be plugged in for P there. So C equals 22 times P plus 10, and P is 6 people. 22 times 6 is 132 plus 10 means it's going to be $142 to go to the fair. Thanks for watching.